Welcome back, everybody. So today we are talking about the 1906 Nobel Prize in Physics, which went to J.J. Thomson. This is possibly one of the most important Nobel Prizes that was ever awarded. It certainly has had more impact on your life than you know. J.J. Thomson is the guy. What he did was it was a solo prize. It was according to the exact wording of the Nobel Foundation was in recognition of the great merits of his theoretical and experimental investigation on the conductivity of electricity by gases. What all that means in plain English is that the dude proved and discovered and did all the theory work to say that the electron is a thing all by itself. It is a particle. It is a subatomic particle. It was the first subatomic particle discovered. And because of his theory work and his experimental work combined, he not only outlined, yes, the electron is real, but here's how you control it, and here's how you use it for something, and here's how you guide it through a field and you get it to go where you want it to. All of that led to a whole lot of stuff that you and I use every single day. So this dude, J.J. Thomson, is the one who really kind of solidified that for us. And the Nobel Committee said, great, you're the guy in 1906. He did this work in the late 1800s. It was done in a cathode ray tube, which might sound familiar for you, because it was actually the subject of the previous prize as well. The guy that kind of developed the cathode ray used the cathode ray to do things, but he did a lot of work on that as well. But this guy, solo prize for the discovery and the proof and the experimental work that said yes, the electron is the electron. It is its own thing. And there is something out there in the world that's smaller than an atom, because before then that had only been theorized and nobody had ever proven it. And the atom was still the smallest building block of nature. And now we know it's not, because this guy proved it. So J.J. Thomson, he's a British physicist from Manchester, England. His mother was from a textile factory. His father ran an antiquarian bookshop. So he wasn't born into, like, he wasn't a baron like the previous Nobel laureate. He wasn't born into, a huge scientific family. He was the first in his family to kind of go this way. Mother from textile world and dad ran an old bookstore, right? So not, a great family to come from, but not what some of the other Nobels came from. So he proved the existence of the electron, and what you see here is a diagram of the nucleus of a larger atom and the electron cloud of that same larger atom. But what this did was it really did break it apart and say, look, guys, there is stuff smaller than that. At this point, the nucleus was still considered one thing. It wasn't considered made up of different things. It was still sort of that center point, but he did prove there was something subatomic. The nucleus was still not even a thing. So the neutron, also think about it, the nucleus is made up of protons and neutrons. We know that now. But the neutron itself wasn't even theoretically figured out until 1920. So 104 years ago, not that long ago. And the neutron wasn't proven to be to exist until 1932, not even less than 100 years ago now. So he was the first guy to do this with something smaller than atom, and there it is. Other notable work he did was he actually discovered the natural radioactivity of potassium, which is actually a little harder to do than you think, especially then. You can do it now, but potassium, which you find in bananas, actually is radioactive. It's not very radioactive. It's very small emission rates. Don't worry about it. Your bananas are not going to kill you. But he was the first one to discover it. And that was interesting because the sensitivity with which you have to build a radiation sensor to prove that is actually pretty impressive for the technology he had at the time. Today, it's a lot easier, but that's today. That's not, late 1800s, early 1900s. So when potassium becomes radioactive, it actually falls into both calcium and argon, but that's sort of a who cares. But and it releases some energy in the process, and it turns out a neutron. But interesting little side note there. He demonstrated hydrogen has a single electron. That was also very important. So he wasn't done just with the discovery of electron. He started trying to figure out which atoms have how many, and he did successfully demonstrate that hydrogen has just one. So that is the smallest possible number, right? So it's the smallest. Physically, it's not the smallest atom. That's actually helium, because the electrons are kind of tighter bound, but hydrogen is the lightest element on the periodic table. That's the lightest one we know in the universe. Okay, so other applications of his work. This all important guy, J.J. Thomson, who everybody needs to write a thank you note to, because he brought us the electron, which brings us electronics, batteries, computers, television, radio, electricity. Yeah, you go on and on and on, and what we use the electron for, and it's a long list. That actually, the picture right there is actually the apparatus he used to prove the existence of the electron. Interesting little vacuum apparatus with a cathode and an anode in it right there, and you know you can run it in a little vacuum and do things. So great guy, one of the Nobel laureates we owe a lot to. He gave us the building blocks of technology that we're still using every single day, because he showed us what was actually inside that atom. And sometimes when you hear people say, "Oh, what's fundamental science good for? Who cares?" Well, if we'd ask this guy that, we still may not know what the hell the electron is, and electronics may not be as advanced as it is. So here we are, right? Fundamental science makes a difference in everybody's life. Sometimes it's a huge difference, sometimes it's not a huge difference, but you never know until you run the experiment. But this guy came up with one that we all know and love. So click like, subscribe, follow wherever you see me. Drop me a line if you have a topic you want me to try to talk about in the science or engineering field. And we'll see everybody in the next video.